We will now create our first world in Webots, which we will be using in the first laboratory, involving just a simple arena like you see here and an epoch robot. For that, we go into the Webots menu and say New Project Directory. What you have to do is you have to select the folder where this should go, and this is maybe a good location, but we want to call it Lab 1 and create it here. So as a first world, we could call it Lab 1 Arena or something like this, and it now creates a couple of directories, which is the Lab 1 directory, which has a world, controllers, protos, plugins, and library subdirectories. Most important for you is the worlds subdirectory, where you store the actual world file, and the controller directory, where we later will create our controllers. So when you start, you have an empty world consisting of nothing. In order to see what is actually in the world, we want to select in Tools the Scene Tree view, which shows all the objects in the world in a tree-like fashion. In this case, there are not any objects in here. In order to add objects, press the plus button, and we can now try to find one of the pre-made objects in Webots by typing arena, and we will find that there is in the Webots project's proto nodes is something called the rectangle arena solid. So we add this, and you see it right here. Now you can take your mouse and move the view around. I usually chose an isometric view like this, and save it, which also saves the view. Now you see this rectangle arena has shown up here in the scene tree, and we want to next add a robot, and we type in epoch to get the epoch robot, which is made by a company called GC-tronic. So make sure you take the robot and not something else here, which is having the name, the word epoch in it, and we add this. Now you can take this object and press Shift to drag it around in the arena. And I recommend you doing this because what happened is place it at the origin of the arena at 0, 0, 0. So everything else we will add will be added here as well. So we won't be able to see it. So let's move this robot a little bit out of the way and press save. Now we want to add our first own primitive into the world and press plus again. And now this time choose from the base nodes the solid primitive. Solid is really the basic primitive for creating your own objects, and everything you see in the world is made of these solid nodes. So once we add that, we don't see anything because the solid by itself doesn't have any information on how it looks like. In order to change that, you have to add children to it, and most commonly what you would add is a shape node. So we get a shape node from the base nodes, and here you see shape can be anything like a box or cylinder or sphere or something like this, and still we don't see anything because we didn't define the actual geometry. So we click on geometry and press plus, and now you can see that when you add a base node, it will actually only show you things that you can add to a shape, which in this case are these geometric primitives, and we select the box here and add it. Now you have a white box which actually protrudes on the other side of the arena. And you can change its size by changing the parameters along X, Y, and Z. And so what we are doing is we are creating a box of 20 centimeter length on each side. Now, in order to move this up, we click on translation and move this up along the Z axis. Now, if you just click plus here or up, then you will change this by 1 meter, which will put the box somewhere here in the sky. Actually, in order to see this, you can't see through the arena, even though it looks like you could. But now you see the box is a little bit too high up. So we want to rather set it to up 10 centimeters, which makes it sit right level. Now that I changed this number here, by the way, when I press plus, it changes in the based on the decimal of the decimal point that I provided. So if I provide another decimal point, I will now change the z-axis by 0.01, so you can see here. But now I want to set this back to 0.1 so it sits flat. Now we don't see anything interesting about this box still, because it doesn't have an appearance, which you can select again from the base nodes, and we usually take the PBR appearance, and we get something that looks like blue, but it actually isn't blue, it is white. Very surprising. Let's set it to red so we see what's going on. Now you will see that the environment is still very dark because we don't actually have a light source except the textured background light. So when you go to the textured background light, you have a chance to change the luminosity, and you will see that as you increase it, it becomes very bright in the environment, but you don't still see your box. So in order to understand this better, we add a point light. Let me click on plus here, base nodes, select the point light and add it. And now what you get is a light source that is a little bit to the right of this block. The reason I see it is because I went to view and went to optional rendering and clicked show light positions. Now I can turn the light position off so you don't see anymore where it is. I recommend you to do that, at least in the beginning, so you better understand what's going on. Now when you turn around, you do actually see that the cube that we created reflects the light source. So you see the light source clearly being reflected here. And now when you click on the solid, the children, and then its appearance, you will see two properties that are interesting here. One is the metalness and one is the roughness. So if I go and the metalness is currently set to 1, reduce this to 0, I see how the cube actually becomes much more red. I still see the point light being reflected very strongly on it. And what happens is it is actually like a mirror, like a dark mirror that I can change the roughness of. And let's put 0.1 here so we better see what's going on, and can use the arrow buttons to slowly increase it. And so as I increase it, the area becomes more diffuse, the light gets reflected less directly, and once I reach the full roughness that is possible, I actually get a red block that is bright on the side where the light source is and dark on the other side. If you want to understand more about light sources and how they work, I encourage you to go to cyberbotics.com and go through the Webots tutorial itself and read up on these light sources. For now, this is what we need to do here in order to play with our robot in the next lab. Alright, one more thing you have to understand about Webots is the entire world is made from solids. Even though some of these things are not named solid, but in this case epoch or rectangle arena. These are so-called protonodes that Webots developers have created for you and then saved in a rather opaque way where you cannot see what the actual children solids are. In order to do that, you can click on any of these protonodes, right click on it and say convert to base nodes. Now what happens is you will see that this is actually not a solid but a robot, which then has children which are different Webots objects like the hinge joints and many solids. So you now see the robot has 2 hinge joints which are for the 2 wheels, and then it has different optical things to make it look like the real robot. And then it has different sensors and a camera and different LEDs, a gyroscope and all sorts of other sensors. It also has other actuators like a speaker, and if you want you can play sounds and then use Webots to actually reproduce them. We won't do this here, so it's just that you see how Webots actually represents things internally and how you could build your own robot. For this, it might be interesting to understand that the tree structure really models how solids are connected. And in this case, we have 2 hinge joints to which the wheels are connected. So you see here there is an endpoint which is called the epoch left wheel solid, and the left wheel solid will be a cylinder, and I leave it to you as an exercise to find out what the diameter of the wheel in Webots actually is.